And finally, let's think about the light is when the light is reflected at the solid surface or interface. And there are two types of the polarization we can think about. If we have one of them is if we have a solid surface, the electric field is sticking out on the screen and then propagating this way and then reflected. And then on the other hand, this type of polarization is electric field is in the in plane and it's propagated and they're reflected. This one is called the S-polarized light. And this one is P-polarized light. You can notice that in the case of P-polarized, only the P-polarized light, when it is reflected, electric field is kind of penetrating into the solid side. But in the case of S-polarized light, oscillation is not penetrating inside the solid side. And there's one important concept of the or phenomenon which is called the Brewster angle. So here's an explanation. At the Brewster angle, the incident light has both polarization of the S polarized and the P polarized, but at some angle, the only the S polarized light reflected, meaning the P polarized light is totally transmitting into the medium. So this angle can be defined by the some angle tangent be equal N2 over N1. So this one is N1 side to N2 side. At this angle, there's no reflection of the P polarized light. So if you could utilize this phenomena efficiently, for example, this is a Wikipedia page of using the polarized law. Only if you use the P polarized light, since you are seeing you cannot see any P polarized light, so there's no reflection of P polarized light. That's why you could see inside the window. But if S polarized light is mixed, there's some reflection from this glass window. That's why the glass window looks like white. But if you use only the polarizer of P and also Y, and then if you are standing at the Brewster angle, you could see inside because there's no reflection of the light. And this kind of principle can be utilized for the microscopy and the spectroscopy too.